All right, today we're going to tackle one of the most mind-bending ideas ever, cooked up by the one and only Albert Einstein. It's a theory that totally flipped our understanding of space, time, and gravity. So let's jump in and try to make sense of relativity together.
So let's start with a question that sounds like it's straight out of a sci-fi movie. Is it actually possible that your clock at home is ticking at a different speed than a clock somewhere else in the universe? Well, Einstein would tell you, absolutely, yes. And figuring out why is our first step to unlocking one of the universe's biggest secrets.
Okay, before we get to Einstein's truly wild ideas, we gotta get a handle on a simple concept, something that for centuries everybody just figured was, well, common sense. It's all about how we look at things that are moving.
And that concept is called a reference frame. Just imagine you're sitting in a car. From your point of view, inside your little reference frame bubble, you're sitting perfectly still, right? But to your friend on the sidewalk, you're whizzing by. And the crazy part, you're both totally right. It all just depends on your frame of reference.
For hundreds and hundreds of years, we used what you could call common sense rules. Let's take an example. Picture a kid walking towards the front of a train. Let's say they're walking at about 1 meter per second. Now, the train itself is chugging along at 30 meters per second. So the question is, how fast is that kid really moving? Well, common sense just tells us to add the speeds together, right? 1 plus 30 equals 31. So for someone standing on the ground watching the train go by, that child is moving at 31 meters per second. Seems super obvious, almost too simple to even question. But as it turns out, this simple addition hides a massive, universe-breaking problem.
And this is where Einstein walks onto the stage. He realized that this easy addition rule totally falls apart when you start dealing with the fastest thing there is, light. So he came up with two brand new rules for the universe that would completely rewrite the book on reality.
Now, the first rule is pretty simple. It just says the laws of physics, like gravity, work the same for everybody, as long as you're not speeding up or slowing down. But that second rule, oh man, that's the bombshell. It says the speed of light is always, always the same for everyone, no matter what. And that changes everything.
Just look at that number, almost 300 million meters every single second. That is the universe's ultimate speed limit. Nothing with mass can even get close. But here's the truly bizarre part. That speed never, ever changes. It doesn't matter if you're standing still or flying in a rocket. Light speed is always light speed.
Think about this for a second. If you were in a super fast spaceship chasing a beam of light, our old logic from the train example says the light should seem slower to you, right? But Einstein says, nope. Even if you're going at 99.9% of the speed of light, that beam of light will still race away from you at the full speed of light. How on earth is that possible?
Well, for Einstein's weird rule to be true, the universe has to do something even weirder. It has to start bending and stretching the two things we always thought were totally fixed: space and time.
And here it is. This is the big secret. To make sure nothing ever breaks its ultimate speed limit, the universe kind of cheats. It messes with the one thing we thought we could always count on. It slows down time. The faster you zip through space, the slower you crawl through time. And this isn't sci-fi. It's a real thing called time dilation.
And we can actually see this happen. Take these tiny particles called muons. They're created way, way up in our atmosphere, and they have a super short lifespan, just 2.2 millionths of a second. They should decay and disappear long before they ever reach the ground. But we see them down here all the time. Why? Because they're traveling so fast, their own internal clocks are taking way, way slower from our point of view. Their time stretches, and that gives them just enough of it to finish the trip. Amazing.
But Einstein wasn't done yet. He then went and completely flipped our idea of gravity on its head. He said, you know what? Gravity isn't some invisible force pulling us down. It's actually the shape of the universe itself being bent and warped.
Picture space-time as a giant, stretchy rubber sheet or a trampoline. Now, if you put a heavy bowling ball, let's say that's our sun, right in the middle, it makes a big dip, right? And if you roll a little marble, that's the Earth, nearby, it doesn't get pulled by the bowling ball. No, it just follows the curve in the sheet. That's gravity. We're all just rolling along the curves in space-time made by heavy things.
So what gives objects this amazing power to bend the universe? It's their mass. And this is where the most famous equation in the world comes in. E equals mc squared. All it's really telling us is that mass and energy are like two sides of the same coin. An object's mass is basically a measure of its incredible super-concentrated energy. And it's that energy that tells space-time how to bend.
So you might be thinking, okay, this is cool stuff for planets and tiny particles, but what's it got to do with me? Well, you might be surprised to hear that relativity is quietly running in the background of your life every single day. You know the GPS on your phone? It would be totally, completely useless without relativity. Seriously. The satellites are orbiting the Earth so fast that their clocks actually tick about 7 microseconds slower than ours every day. It doesn't sound like much, but if the GPS system didn't correct for that tiny time difference, your map directions will be off by miles within a single day. It's also essential for scientists who use giant machines to smash particles together, and it's the only way we can begin to understand the craziest objects in the universe, black holes.
So what this all really means is that our reality is so much weirder, more flexible, and more amazing than it looks. The universe isn't some fixed, rigid stage. It's a dynamic, stretching, and bending fabric where even time isn't what it seems. And that just leaves you with one last incredible thought. If our common sense was so wrong about time and space, what other secrets about how the world works are just waiting to be discovered?